Assalamualaikum and hello everybody. My name is Farimur Bijasmani. I am from Group 9 and we will present about Chapter 9 Electric Components. So I would like to introduce my team members. First is me, Farimur Bijasmani, batch number 277559. Second is Siam Tin Yang, batch number 278361. Number 3 is Lai Loyan, 277999. And lastly, Hong Yong Wei, 278147. So, we will explain about integrated circuit and then rectifiers and lastly, electric symbols. So, I will pass to next presenter. Thank you.
Hi Doctor, my name is Arakian and my track number 277999. Today I would like to present the types and packaging of integrated circuits. The classification of different types of IC based on their chip size, which are SSI, MSI, LSI, VRSI, VRSI, WSI, and SOC. For example, SSI consists of only a few transistors and play a critical role in every LSB project. MSI consists of some hundreds of transistors and achieve better economy and advantages compared to SSI. VRSI consists of transistors from hundreds to several billion in number. VRSI consists of transistors in excess of more than 1 million, and later WSI and SOC were developed. Typically, IC packaging is the last production stage of semiconductor device. During this stage, the semiconductor blocks get covered in a package that protects the IC from potentially damaging external elements and the corrosive effect of the edge. The package is essentially an encasement designed to protect the block and also to promote the electrical contacts that deliver signal to the circuit board of an electronic device. Next, there has a video explain more detail about the types of ICs.
ICs can be grouped into categories depending on the nature of input signals. They are A. Linear or analog ICs and B. Digital ICs. In linear ICs, the input signals are analog signals which change smoothly and continuously over a range of values between a maximum and a minimum. In this case, the output is almost directly proportional to the input, that is, it varies linearly with the input. Operational amplifier is an example of linear IC. In digital ICs, the input signals are digital signals that have only two values. They contain circuits such as logic gates. Based on the number of logic gates present in it, digital ICs can be further classified as SSI, MSI, LSI, and VLSI. SSI, small-scale integration, has less than 10 logic gates per square millimeter. MSI, medium-scale integration chips, have less than 100 logic gates per square millimeter. LSI, large-scale integration chips, have 100 to 1000 logic gates per square millimeter. VLSI, very large-scale integration chips, have more than 1000 logic gates per square millimeter.
So, I will explain about other developments for the IC integrated. So, other developments, first is in the 1980s, programmable integrated circuit were developed. This device contains circuits with logical function and connectivity can be programmed by the users rather than being fixed by the integrated circuit manufacturer. So the second one is the techniques perfect by the integrated circuit industry over the last 3 decades have been used to create microscopic machines known as MEMS. These devices are used in variety commercial and defense applications, including projectors, inkjet printers, and are used to deploy the airbag in car accidents. So next one is, in the past, radios could not be fabricated in the same low-cost processor as microprocessors. But since 1998, a large number of radio chips have been developed using CMOS processors. Examples include Intel DECT cordless phone or Atrox 802.11 card. And lastly, single chip can be programmed to implement different LSI type functions such as logic gates, adder and registers. Current device named FPGAs fail programmable gate arrays can now implement tens of thousands of LSI circuits in parallel and operate up to 400 MHz. So that's all from me. We will continue for the next topic. Thank you.
Hi everyone, my name is Heng Yong Wei and my battery number is 278147. Today I would like to talk about rectifier. Rectifier is an electrical device that is made of one or more than one diode that convert the alternating current AC into direct current DC. This is used for rectification where the process shows that how it converts AC into DC. Rectifier are the main part of a DC power supply. There are several types of rectifier, but today we will talk about two types of rectifier, which is half-wave rectifier and full-wave rectifier. A half-wave rectifier is defined as a type of rectifier that only allows one half cycle of an AC voltage waveform to pass, blocking the other half cycle. Half-wave rectifier are used to convert AC voltage to DC voltage and only require a single diode to construct. Let's say the circuit assuming the diode is ideal. When the input side more than 0, the diode is followed biases and so switch on, therefore the output side is equal to input side. But when the input side is less than 0, the diode is reverse bias. When switch off and the output side is equal to 0 voltage. You can look at the second figure. Next we will move to full wave rectifier. Now let us look at the full wave rectifier. A full wave rectifier is defined as a type of rectifier that converts both half of each cycle of an alternating wave AC signal into a pulsating DC signal. Full wave rectifiers are used to convert AC voltage to DC voltage, requiring multiple diodes to construct. Full wave rectifier is a process of converting an AC signal to a DC signal. The first figure is show the full wave rectifier design use two diodes and a circle tap AC supply, and the second figure is a waveform show. The center tapping implies the two source voltage V1 and V2 are half cycle out of a phase. We see that the diode D1 conduct when source V1 is positive and the D2 conduct when V2 is positive, giving the waveform is output side. Now we will look at the capacitor filter. It can see from the previous two waveform, output side is not very smooth. For many applications, it decided to have a much smoother DC waveform, and so its filtering circuit is used. For the first figure, you can see it. The waveform produced by this filter half-wave rectifier is shown in second figure. It illustrates the ripple. Then the ripple is defined as the difference between the maximum and minimum voltage on the waveform. You can look at the third figure. Hence, the analysis is obtained for the capacitor connect across the half-wave and full-wave rectifier. And the purpose of the connecting capacitor is proven benefit because it can remove unnecessary ripple from the generate output. Thank you.
My name is Jian Yang and my machine number is 278361. And now I will try to explain what is electronic symbol. An electric symbol is a pictogram used to represent various electrical and electronic devices or functions, such as wire, battery, resistor, and transistor. In a schematic diagram of an electrical or electronic circuit, these symbols are largely standardized internationally today, but may vary from country to country, or engineering discipline based on traditional convention. Next, electrical symbol and electronic circuit symbol also are used for drawing symmetric diagrams. There are some symbols represent electrical and electronic combination which we can look after the next slide. This is some of example of electronic symbol which I discovered, and we can see it from the table. For example, such as cell, battery, light bulb, motor, switch, fuse, emitter, voltmeter, resistors, and ground connection. Different functions have different distribution, such as cell, source of current electricity, motor, convert electrical energy into mechanical energy, and emitter is measure current, and voltmeter is used for measure voltage, and the resistor is a device that impede the flow of electron, and the ground connection is uses to connect the circuits to the earth.